Hello everyone, this is Ketish here. In this video, I'm going to go through question number 11 from the AQA 2022 Physics Paper 1 Higher Tier. This question is on the topic of electricity. Figure 12 shows some hair straighteners. Hair straighteners contain heating elements. When the hair straighteners reach normal operating temperature, an LED turns on. Draw the circuit symbol for an LED in the box. Now, an LED or light emitting diode. The symbol for that would be very similar to a diode. So that's a diode, and you draw a circle, and two arrows to show that the light is being emitted. Now, you could draw that without the circle as well, and you'd still get the mark. Now, this question was actually removed from the exam. So as you can see, so here's the possible two answers. You can draw both of them. Now, due to an incorrect advanced information guidance, to avoid any students being disadvantaged, question 11 was discontinued and all students were awarded the full marks. So meaning that the entire physics paper was less than was marked out of less than 100 marks. Anyway, next part, figure 13 shows the circuit diagram for the hair straighteners. Each resistor represents a heating element. The power output of the hair straighteners can be changed by closing different switches. So what you're seeing here is a parallel circuit, because there's branches. Now these two, if I label that as resistor 1 and resistor 2, these two are in series together. Resistor 3 and resistor 4 are in series to each other. Resistor 5 and resistor 6 are in series to each other as well. Why do the hair straighteners not turn on when only switch 2 is closed? Now, if you close switch 2, switch 1 is still open. That means the circuit is not complete. So you could say the circuit is not complete, or there's a gap in the circuit, or you could say S1 needs to be closed. So any of the following answer is correct. There's a gap in the circuit, or S1 needs to be closed to complete the circuit, or S1 needs to be closed to turn the hair straighteners on. 11.3. The hair straighteners have a maximum power output of 120 watts. So that would be my power. The energy transfer to the hair straighteners to reach normal operating temperature is 3.6 kilojoules. So that's my energy. Calculate the time, which is T, taken for the hair straighteners to reach normal operating temperature when operating at maximum power. So the equation that links all three of them is power equals the energy divided by the time. Now, the energy they have given you is 3.6 kilojoules. You'll have to convert that to joules. So you need to multiply that by 1,000, which gives you 3,600 joules. Now that carries 1 mark. In order to calculate the time is the energy divided by the power. So 3,600 divided by 120 will give me 3,600 divided by 120. That should give me 30 seconds. Question 11.4. Figure 14 shows the hair straighteners circuit with S1 closed. Switch S2 and S3 are then closed at the same time. Explain what happens to the power output of the power supply. Now, you would automatically assume that because you're engaging all of the resistors, it should actually increase. Now you need to understand what happens to the total resistance for you to be able to answer this question. I think it's this part there, the reason why they actually remove this question, because they're not actually meant to ask questions on resistance in parallel, just in series. So here's the answer. The total resistance of the circuit decreases. Right? That bit you should know, but you don't really need to know how it's actually worked out. When you have resistors in series next to each other, then the resistance adds up. So if I was to give you a little bit of notes, right? So if you have resistors in series, the total resistance simply adds up depending on the number of resistors you have. Now, if you have resistors in parallel, this is the equation that you will be using. Now, if you use this equation, you'll find out that the resistance actually drops. So the total resistance of the circuit decreases. Now, power here, power depends on the current and the voltage. The voltage is fixed, so is the current. So what happens when and this equation V equals IR. If the resistance reduces, then the current should actually increase, because the voltage is actually kept the same, because that's the mains voltage. So the current increases, and if the resistance drops, the current would increase. If the current increases, then the power output will also increase. Right? So these two equations are linked together to be able to answer this question. That brings us to the end of question number 11 and the end of this paper. Thank you for watching. I will catch you in the next video.